Third and final assessment for logarithms and exponent functions. Again, you guys need to pay attention, take the video seriously. This is not going to be rushed through the video. Oh, Hermson will bail me out on the test if I don't know it, okay? It's not happening. So, what we have here in the logarithms, okay, is I have to find out what the x equals, which is very easy to do out of a logarithm expression. You just figure out how many of 3's it takes to multiply to 9. Well, 1's not going to do it. That's 9, so it takes 2. So x is 2. Okay, same name of the game here. Figure out how many 5's it takes to multiply to 125. Product's 125. 5, 25. Remember, it's 125 though. So we got to add another one. We'll see if that's 125. It is. So it takes 3 factors of 5. Now here we got log base 1/10 of 100 equals x. Now instead of 10, it's the reciprocal of 10, which is 1/10. So all I know is that makes my power negative. And after I know that that's negative, I can forget the fact that it's 1 over 10 and just focus on 10, okay? Rather than have the fraction convoluting and making things more difficult, I just now go with 10 as long as I get the negative. How many 10's is that? That's 100, so it takes 2, but it's to the negative 2 because 1/10 to the negative second power equals 100. Okay, next one, I got to figure out how many 6's it takes to multiply to 36. 1, 2, bam, we're there, 2. That's pretty easy. Now it gets a little bit tougher. This takes a little bit of looking over. Now you're solving for x, but the thing is, x is now an exponent, okay, that you're solving for. So 6 to the power of 2x plus 1, I put my caret symbol and then split the exponent from the base. And then it's also happening on the other side where the x is in the power. The x I'm trying to solve for is part of the exponent. So again, put a 1 there, circle split. This is happening on both sides, the exponent of x's. So I make my power of x. When it is two-sided like this, this is the strategy we'd use. So I use 6 and 216. Now I got to figure out how many 6's it takes to multiply to 216 if I'm able to. If not, we got to rewrite both of them, but right now just 1 will probably do. 1, no, that's 36. And that's 216. So I'm going to replace that with 6 to the power of 3. So I want these bases to both be 6. Now this was already 6, so we just put the 2x plus 1 power. This right here needs to be rewritten because this was not a 6. It takes 3 6's to multiply to 216. And then I put a parentheses in the original power. Okay, now I can cancel out the 6's and now it becomes an easy equation to solve. I have 2 times x plus 1 over there. Over here I need to distribute 3 to both terms, not just the 1x, and that's 3x plus 9. Okay, my x's are on different sides, but they are like terms, so we'll subtract 2x because they would go together. So 1 is equal to 1x plus 9, and then I minus 9. 1 minus 9 is negative 8. So negative 8 equals 1x, and then divided by 1 is negative 8 still. Okay, now the next one is a different strategy because I am solving for x, and yes, x is in the power, but it's just on one side, so I would not use the glasses or graphic organizer. Instead, I set the expression 2x plus 7, because that is my exponent, equal to the log over log ratio. Now, I know 3 is going on bottom because that's your base, okay? You got to put that on bottom. Now, do we have a multiplying number out here where my pencil's at? No. So I can just put 48 in the numerator. So on this side, I put 2x plus 7. And on the other side, I need to divide log 48. Close parentheses. Divided by log 3. Close the parentheses. I got 3.52. So for some of you saying, how do I punch it in my calculator? Well, how about you do it along with me and you'd learn it, okay? Minus 7, minus 7. 3.52 minus 7 is negative 3.48. And then I divide by my 2. Negative 3.48 divided by 2 is negative 1.74. And there's my solution for x. So again, these are going to take some looking over. If it's happening on both sides, you go to the classes. Happening on one side, if it's one-sided, you go to the log ratio. Exponent equals log. 3's denominator, 48's in the numerator. Okay, now we have a graph. Y equals 3 times 2 to the x minus 4 power plus 5. And what we have here, since the x is a power, this is called an exponential graph. So we make an XY table. We're going to make a domain of inputs. Now, we don't do the 9, 4, 1, 0. That's when x is in a square root. The square root's got nothing to do with this problem. So here's what I do. First off, I circle the part that's the power. Okay? No, you're not doing log over log, none of that stuff. This number here, the 2, okay, the base of the exponent is a whole number. So if it's a whole number, I start with positive 2, positive 1, 0, negative 1, negative 2. Okay? And no, I'm not just starting with 2 because that's a 2 there. If that was a 5 there, I'd just do the same thing. 2, 1, 0, negative 1, negative 2. Okay? That is a whole number there. Now, there's also a line, because the domain's unrestricted. You can pick whatever you want. You can go 5 through negative 5 if you want. But the range is restricted because there's that on an exponential graph, there's an imaginary line you can't cross, known as the asymptote, A-S-Y-M-P-T-O-P-E. Okay? To find what that is, we're going to go jump to negative 20, negative 30. Now, instead of 2, if that would have been 1/2, 1/2's not a whole number. Then I'd start with the negatives, negative 2, negative 1, 0, 1, 2, and then 20, 30. Okay, it just keeps on rolling. Okay, now here's how we're going to calculate the outputs. That minus 4 causes a bit of a conundrum with me, okay? I mean, it really does. I would like that minus 4 not to be there so I could just do the power of x, okay? So here's what we're going to do. We are going to delete the 4, okay? Delete that minus 4 and just put plus 4 at the end, but we're going to get our outputs first, okay? We're going to add 4 to all these just before I make my coordinates. But these are the numbers I put into the calculator, okay? Do not plus 4 until the y outputs have been calculated. I'm going to repeat that again. Don't plus 4 till all the y outputs have been calculated using these numbers, okay? So I have 3 times 2. Again, putting a plus 4 there above the x allows you to delete that. Okay, if it said plus 4, I would minus 4. Okay, so 3 times 2 to the power of 2 plus 5 is 17. Hit the up key, and then 1, 11. There's no pattern to this either. 0. Now I have to reset it because I'm doing negatives. 3 times 2 to the power of negative 1 plus 5 is 6.5. $5.75. Now I'm going to recalculate because now I'm doing double digits. 3 times 2 to the power of negative 20 plus 5. Okay, it's practically 5. That's really close to. And then 30. Okay, that's 5 too. So that asymptote's at 5. Now before graphing is when I add the 4. So that's 6, 5, 4, 3, 2. You don't need to do it with these because you're not going to graph those. Okay, so I have to go by 2's so I can hit 17. Okay, now 5 is the asymptote. So go 2, 4, 5 and make that line that you cannot cross because your range is restricted. So 6, 17. 1, 2, 3, 4, 5, 6. 2, 4, 6, 8, 10, 12, 14, 16, 17. 5, 11. 1, 2, 3, 4, 5. And then 10, 2, 4, 6, 8, 10, and then 11. 4, 8, 1, 2, 3, 4, 2, 4, 6, 8. And then all that's going to happen, I don't even need to graph the other ones. We're just going to go infinitely higher in that direction. Here we just get closer to the asymptote line. Don't cross it. Okay, now, just to get that in your head, I'm going to make up another problem, okay? 3 times, let's go 4 to the x plus 2 power minus 6, y equals. Write that down. I know that's not on your paper. I want that written. There's only one graph on the test, but you need to practice it a couple times because we've done it before, but it takes a while. Again, it's exponential. So exponential is the 2 through negative 2, but where do I start? Well, again, I have a whole number, so I start with the positives before going to the negatives. And that helps me find my asymptote. Again, if that's 1/4, then you start with the negatives, go to positive, and then 20, 30. And what is my asymptote? I don't know. I'm going to find that out down here. Okay, I don't want that plus 2 there, so cross it out and just put minus 2. Okay, and now you can do these inputs. Don't minus 2 yet until you get your y column filled out. 3 times 4 to the power of 2 minus 6 is 42. Power 1, 6. Power of 0. 4 to the 0 power is 1, so it'd be 3 times 1 minus 6, negative 3. Negative 2, negative 1. Because 4 to the negative first is 1/4. So negative decimal then. Negative 5.8. 5.81. And then negative 20. So 3 times 4 to the power of negative 20 minus 6. See, if I put that there, I can delete that. Okay. Negative 6 and negative 30th power is going to be the same thing. Okay. So there's no way to get past that negative 6 point. Okay. Now before we go to the graph, we need to minus 2. So that's 0. Minus 2 is negative 1. Minus 2 is negative 2. Negative 3. Negative 4. And that's now what I'm going to graph. Remember, don't do that till after the y's are calculated. The y's are set at that point. Now you're like, well, why do we have to do it with the x as well? Because remember, I had 2 there originally. Well, what is 0 plus 2? 2. Negative 1 plus 2 is 1. So it'll have it exactly how I want. Remember, don't do that operation until the y's are calculated. Okay, so I'm going to go by 5s, negative 6. So again, we're going to go down 5 and then part way. 0, 42, 5, 10, 15, 20, 25, 30, 35, 40, 42. Then go left 1, 5, 6. Negative 2, negative 3, left 2, negative 3's here. And then from there, I don't really need, I just need basically to actually plot 3 points. Because we go higher that way, and then against the asymptote the other way. Okay, and that is how you graph when you have x, your input, as in the power. 2 through negative 2, you got to remember the asymptote. Remember, if x has a plus or minus with it, you scribble it out, just put it over the x, and calculate your y's, then do the plus or minus. Okay, I deposit $500 in a bank account that earns 4% interest compounded quarterly. How much will this account be worth in 10 years? So that's the value. Okay, so your 2 units of importance are dollars and years. And then per year, dollars per year. I don't know that, okay, because it's 4% per year. It's not a money amount, so it's not a linear equation. Instead, it's an exponential function where I repeatedly multiply. Now, interest is adding 4%. Now, right away, you need to divide that by 100, okay, if it's a percent, and write that as plus 0.04. And then put a 1 down there with a plus sign. Now I set up my equation, my exponential. I have an original amount multiplied by another amount, and that one's to the power with x equals my new amount. So again, this is my percent. These are both y values, so they'd both be money values from the story problem. And then this is original, and this is new. Now let's talk about our percent. First, look for the phrase quarterly. If it's there, this needs to be divided by 4, and we need to put 4 here because it's 4 times a year, and then the percent's divvied up by 4. If that compound quarterly is not there, you just don't put the 4 there, and you add the 0.04. But because it was there, we need to divide that decimal by 4 and put the 4 there. 0.01, so that's 1.01. That is my percentage. So again, percent, rewrite it in decimal form, okay, 1 plus, because 1 is 1 whole. It's like 100%. And if quarterly is there, 4, divide the decimal by 4 before adding. Okay, now the money you originally have is $500. Okay. The x is the years, and that's 10, okay? So 4 times 10 is 40. I do not know that. Money is y. Now, there are no expressions happening to the y, okay? Nothing. Punch that into your calculator. So 500 times 1.01 to the power of 40. I have my answer, 744.43. That easy. Y has no operations. You plug the other side in. You don't mess around. All right, next one. A school's population is increasing at a constant rate of 5% each year. If there are currently 800 students in the district now, how many years will it take for that amount to reach 1,000 students? So I have years and students. So X is years, Y is students. So students per year. Again, it's a percentage. So again, it's percent per year. It's increasing. Now rewrite that as plus 0.05. That's your first move. Okay. Then line up your exponential growth function to the power of x equals that. If that's a percent, that's the go-to. It's an exponential function. So this is my percent. These are both y values, so it would be students. Okay, we got to do our percent first. Do you see the phrase quarterly anywhere in that problem? No. I'll also put the 1 plus. You don't see that anywhere, so you do not divide that decimal by 4. You put 0.05. You also don't put a 4 in front of the x. It's happening once a year, not 4 times. So again, compare it with the first problem. I had 0.04, 1 plus, because it's going up. If it's going down, it's 1 minus. Decimal divided by 4, because quarterly, and we put the 4 there. Divide by 4, that's what we're adding. This problem, quarterly, is not here. It is not happening 4 times a year. It's happening once. So don't divide that by 4. Just put that here and don't put the 4 there. So 1 plus 0.05 is 1.05, and that is your percent. Okay, now the original number of students is 800. X is years, but I don't know that because that's my answer. Okay. So how many students do you have is your new that. Now the X definitely has operations with it. It's a power and we got multiplication. So I circle split. Now I got to fool around a little bit. So that power of X equals log divided by log. 1.05 is in the denominator. Now, for the numerator, check in front. Oh, I see a multiplication of 800. So I would divide by 800, not subtract. And I take 1,000 divided by 800, which is 1.25. Calculate it, and I don't need to divide by 4 because it wasn't quarterly. So log 1.25 divided by the log 1.05, boom, 4.5 or 4.6 or 4 between 4 and 5. Okay, last problem. A team's attendance has increased at a relatively constant rate for the past 8 years. 8 years ago, the average attendance was 4,000 people. Now it's up to 50,000 people. Find the rate of increase. Years and people. So years is X, people is Y. It's people per year. There is no people per year because it's a percent. A constant rate is a percentage, okay? So that should be constant percent. I would tell you that, but I forgot to. So it's a percent, but I don't know the percent, so I use P. So again, those percents where it repeatedly changes by percentage needs to be an exponential function. Original times a percent to the power, because it's every year, equals blank. Okay, so I got my percent, and then again, Y is people and people. All right, now I don't know my percent because I can't do much with it. It's P, okay? Now people originally is 40,000. X is years. I know I have 8. Because if I have P there, all the other ones I have to know. And then 50,000. Now, you're not using log over log. The variable is not up here. It's down here. Okay? So, what I would do is write that as 40,000. P to the 8th power equals 50,000. Then I got to get that power by itself, so I divide by 40,000 because I'm going to use an 8th root, but first I have to divide. So 50,000 divided by 40,000 is 1.25. Now, any power, whole power, we use a root, and I need an 8 in the index. So to find the 8th root, you go 8 second caret 1.25, okay? 1.03 Then, before you fill your percent, you go 1.03 minus 1 equals, you don't have to write that down, and then multiply by 100, and you have your percent, so 3. That's how you solve the P, okay? You don't use log over log, you just basically going to divide, then find the 8th root of whatever that is. But again, where I do have the percent, I can't emphasize that enough, okay? You write it as a decimal form, and if it's quarterly, you got to divide the decimal by 4, put it there. If it doesn't say quarterly, don't divide it by 4, add it, and don't put the 4.